Imagine having 1,000 apples stocked up inside a tiny room which has no doors and windows. Imagine yourself within this room having to consume 10 apples a day to sustain yourself. Within 100 days, all apples would have turned into your own waste inside this tiny room with you in it. Now imagine that the apples represent all of the carbon that humans have dug out of the earth in the form of petroleum, coal, and natural gas since the beginning of the Industrial Revolution. If the apples are the carbon, the room you were inside is the earth, and you represent the entire human population for this time period. The carbon that has been taken out of the earth has been used up to sustain our ever-growing need for energy, and is now a part of our atmosphere. And just like your own waste inside this tiny room, it is not going anywhere, not fast enough. Not only is it not going away, it is also destabilizing our climate patterns at an alarming rate, triggering feedback loops that result in a cascade of global effects, deepening its overall impact, while we gleefully continue feasting on those apples.
B.A.S.E.S stands for Biorecycling for the Advancement of Sustainability on Earth and in Space. And it has been designed as an interactive educational platform for conveying how our engineered systems can mimic natural biorecycling processes to ensure our environmental sustainable survival on planet Earth and in any future space colonies we may be willing to establish on other planets. Since humans have been producing waste at an unprecedented rate, environmental engineers have come up with technologies to speed up the natural breakdown of waste. One of these technologies is called anaerobic digestion. Anaerobic digestion relies on microorganisms that can break down waste and convert it into biogas and essential nutrients. B.A.S.E.S features an anaerobic membrane bioreactor that does anaerobic digestion and filters out the water that comes out of the process at the same time. The water carries essential nutrients and can be used to fertilize plants to create more food for our consumption. So the nutrients that come from food and make their way into our waste can be biologically recycled or biorecycled back into our food, closing elemental loops for nitrogen, phosphorus, potassium, and other nutrients. Plants also take up carbon dioxide from the atmosphere and turn it into plant matter, reducing the amount of carbon dioxide in the atmosphere. Other kinds of organic waste, like wastewater, can also be broken down by anaerobic membrane bioreactor. The water and nutrients that are released can then be used to grow algae, to produce fine chemicals, pharmaceuticals, bioplastics, biofuels, and other useful products inside an algae photobioreactor. Algae are autotrophic microorganisms, meaning they take up carbon dioxide from the atmosphere and turn it into cellular products, just like plants do. Both plants and algae require sunlight to grow and complete elemental cycles for carbon and other nutrients. In addition to showcasing these technologies, B.A.S.E.S also has an LCD screen that can display outputs from temperature, pH, and conductivity sensors that are installed on the reactors, as well as play educational media and run custom-made educational games. The LCD screen is connected to a tablet that allows users to interact with it.
So to teach concepts of isolated systems, of closed loops, of things operating in cycles, we can draw this on the board, but it'll get awfully boring for kids. So they like to see things happen. They like to see things move. They like to have things they can touch. So in B.A.S.E.S, we capture those things in actual miniature versions of reactors that we actually have in the lab. And what's cool also is that we're trying to connect this with evidence-based learning. Right, so you have basically things that kids can measure. They can collect data using B.A.S.E.S as a platform, and then using the data, you can interpret the data, you can draw conclusions from it, and using the latest wireless technologies, B.A.S.E.S is compatible with Chrome, with Apple TV, with a variety of wireless systems. So kids or teachers can measure things in the classroom and then send it up to the screen so the whole class can see. So it becomes highly interactive, evidence-based learning. They measure something, they see it, now they kind of get it.